Now we need to look at SI system of fundamental and derived units. First of all, we have the list of fundamental units. The ones that we need to know are the meter, kilograms, seconds, amps, amperes, and Kelvin, also the mole. Now all other units that we use can be derived in terms of these units. We'll look at some examples. Force is measured in newtons, but it can be expressed in another way. It can be expressed in not derived units but SI units, fundamental units. F is equal to MA. Now F is a measure of force, which is measured in newtons. We know mass is measured in kilograms. Acceleration is measured in meters per second squared. So it's the unit of Newton can also be written as kilograms meters per second squared. What about energy? Energy is the unit is joules, but this is not a fundamental unit. What we need to do is find out a formula which uses joules, and one that's good is the work done is force times distance. Now we know the force is kilograms meters per second squared times distance, which is meters. So we have kilograms meters per second squared times by meters, and that gives us kilograms. Meters times by meters gives us meters squared per second squared. So this is finding the fundamental units from a derived unit. And here we have some examples here. We've just calculated these two. Power can be expressed as kilograms meters squared per second cubed, and so on. All these units can be expressed in terms of kilograms, meters, seconds, amps, and Kelvin. We need to be able to convert between different units of quantities. You know that joules and kilowatt hours, joules and electron volts. We haven't covered this yet, but we will need to be able to do this in the future. State units in the accepted SI format, Standard System International. So, for example, we don't really write meters slash second squared, meters per second squared. The standard is meters seconds minus 2. Why do we do that? In an exam, you're not going to have marks taken off if you do it this way. But when it starts to get rather complicated with all these strokes, it makes it tidier if it's written this way. Okay, state values in scientific notation and in multiples of units with appropriate prefixes. For example, nanoseconds and gigajoules. Here we have it. We'll start with 10 to the 3, which means 1,000, which is kilo. 10 to the 6 is mega. 10 to the 9 is giga. 10 to the 12 is tera. 10 to the minus 3 is milli. 10 to the minus 6 is micro. 10 to the minus 9 is nano. 10 to the minus 12 is pico. You need to remember these. Notice there is a pattern that generally when it's greater than 1, the abbreviation is going to be a capital letter, with the exception of kilograms or kilos. And when it's less than 1, the abbreviation is a small